All right, so you sent over some really interesting material about improving code, and specifically this idea of something being a task agnostic.
Yeah, it's a fascinating concept.
It really is, and that's what we're going to dive into today. We want to unpack what that actually means, this task agnostic approach, particularly for code improvement, and maybe why it's useful even if, you're not deep in code every day.
Absolutely. And one of the core things in those sources was this task-agnostic code improvement plan.
Right.
It's laid out as this kind of standardized protocol, something you can apply to pretty much any code base. Doesn't matter the language, doesn't matter the context.
So very flexible then, not just coding tips, but a different way of thinking about problem solving.
Exactly. It's about the framework.
Okay, let's tackle that head on then. Task agnostic. It sounds a bit like a silver bullet, maybe. A one-size-fits-all thing.
Well, yes and no. It's not about having like a magic fix for every single unique problem. It's more about having a method, a process that works universally, something you can apply across different tasks or contexts without constantly tweaking it for every little specific detail.
So the focus is more on how you do things, the general process, rather than needing super specific rules for every situation.
Precisely. It prioritizes those generalizable processes, analyzing, testing, structuring over task-specific instructions. That's where the adaptability comes from.
Oh.
It really shifts the focus. It's about how you solve the problem, the steps you take, rather than getting bogged down in the specifics of that one particular issue.
I see. So less about fix line 57 and more about here's a reliable way to find and fix issues like the one on line 57, wherever they might pop up.
You've got it.
Yeah.
And that task-agnostic code improvement plan we mentioned, that's a perfect, concrete example of this whole philosophy.
It's like a universal strategy guide for code health.
Exactly. The sources detail it quite clearly, step by step. It starts with initial assessment and prioritization.
Okay, step one, what does that look like?
You basically take a high-level look, a bird's-eye view
Yeah.
of the whole code base.
Right.
The goal is to spot the really critical stuff first. Maybe known bugs causing headaches for users, or performance bottlenecks slowing things down, or maybe security risks.
So finding the big fires first, focusing on impact.
Exactly. You want to put your effort where it counts most.
Yeah.
You wouldn't repaint the shed if the house roof is leaking. Right?
Good analogy. Okay, so after that initial assessment, what's next on the plan?
Step 2 is static analysis and testing. This is where you bring in tools.
Automated tools.
Yeah, automated tools that scan the code. They look for things often called code smells, basically, patterns that hint at deeper problems.
Okay.
They also flag unused or dead code and potential logic errors. But crucially, this step also involves running tests, unit tests, integration tests.
Testing what's already there.
Exactly. Think of it as checking that the existing functionality works correctly before you start messing with it. You need a baseline. You need to know what good looks like right now.
Right, like getting your vital signs checked before surgery. You need that starting point confirmed. That seems really fundamental. What happens after the analysis and testing?
Then you get to the core of the changes, code restructuring and refactoring.
This is where the hands-on coding happens?
Pretty much. The sources talk about breaking down big, clunky pieces of code, splitting large functions or classes into smaller, more focused ones.
Making it more manageable.
Yes, and also extracting reusable bits of logic, so you don't have the same code copied and pasted all over the place.
DRY principle, don't repeat yourself.
Exactly. And applying established design patterns, known solutions for common problems, to make the structure cleaner, more understandable.
And improving readability, too, I imagine.
Definitely. Things like using clearer names for variables and functions, getting rid of redundant code, is all aimed at making the code easier to maintain and update later, and also helping it scale handle more load or complexity in the future.
Makes sense. Easier for the next person or your future self to figure out what's going on, and scalability is always huge. Okay, what's step 4?
Step 4 is documentation and maintainability. This one's critical, but sometimes overlooked.
The comments and manuals?
Basically, yes. Adding clear comments inside the code to explain anything tricky or non-obvious, and also keeping the higher-level documentation up to date. Things like descriptions of the overall architecture or how different APIs work.
Why is that so key in this task-agnostic plan?
Because good documentation acts as a universal guide. Anyone needing to understand or change the code later can get up to speed much faster. It saves enormous amounts of time deciphering things. We've all been there staring at code, wondering what on earth it's about.
Oh, absolutely. Trying to understand uncommented, undocumented code is painful. It's like code archaeology sometimes. So good docs are invaluable. What's the final step?
The last one is monitoring and iteration. This is about checking what happens after you've made the changes.
So follow-up.
Exactly. Setting up performance monitoring, for instance, to track if things are running faster or slower, using more or less memory. The sources really stress that code improvement isn't a one-and-done deal.
It's ongoing.
It's a cycle. You need to look back at your benchmarks, see if your refactoring actually worked as intended, and be ready to tweak things further as the code evolves or new issues crop up. Continuous improvement.
Okay, so that's the whole plan. Assess, analyze and test, restructure, document, and monitor and iterate. And the striking thing, like you said, is that focus on the how, not the what.
Precisely.
It's a defined process applicable anywhere. And what's interesting, thinking about those sources, is it's not just about finding bugs, but about consciously deciding where to spend your limited time and energy, that prioritization.
That's a key insight, yes.
Yeah.
That kind of proactive decision-making, focusing resources on high-leverage points, is something this task-agnostic approach really encourages. It's a trait you see in effective problem solvers generally.
And the power comes from that abstraction, right? Because you focus on the methodologies, assessing, testing, restructuring, documenting, iterating these steps. These steps are useful no matter the language or the specific problem.
That's the core strength. Those fundamental actions remain valuable and relevant across different contexts. It gives you a reliable, consistent way to approach improvement.
And consistency saves effort. The sources pointed that out. You're not reinventing the wheel each time. You have a go-to strategy.
Exactly. It builds efficiency. Whether you need to boost performance, improve maintainability, handle more users, the fundamental process gives you a starting point and a path forward.
So we've seen how this works for code, but you mentioned this how over what idea has broader applications. Let's explore that a bit.
Yeah, this is where it gets really interesting, I think, this task-agnostic thinking. It's not just for software.
How so?
Well, think about the underlying principles. Focus on process, be adaptable, prioritize the how. These are valuable pretty much anywhere. Consider a really basic problem-solving process. Define the problem, brainstorm solutions, test them out, implement the best one. That's a task-agnostic how.
Right.
You could use that same general process whether you're, I don't know, fixing a dripping tap or planning a huge marketing campaign. The what changes completely, but the how, the steps, remains useful.
That's a great point. It makes you think, in your own work, whatever that is, or just daily life, are there patterns, challenges that keep cropping up in slightly different forms?
Exactly. Could you identify a more general task-agnostic process that would streamline how you handle them, instead of tackling each instance as totally unique?
Finding those core how-tos that apply more broadly.
And that really raises a question for everyone listening. Think about the tasks you do regularly. Do you find yourself making very specific, bespoke solutions every time, even if the underlying type of problem is similar?
Yeah.
Could you step back and define a more general process, consistent how, that would probably lead to good outcomes more reliably, regardless of what the particular details each time?
So wrapping this up, the big takeaway isn't just about cleaner code, though that's obviously a goal of the plan we discussed.
Right, it's broader.
It's more about recognizing the power of having these adaptable processes, focusing on the method of solving problems or making improvements, rather than getting lost in the weeds of every single specific instance.
Cultivating a more strategic, flexible mindset, maybe.
Yeah, exactly. A more flexible way to approach challenges in general.
Which leads to a final thought, perhaps, for you listening. Consider those tasks you face often. Could you actually define a task-agnostic process for them?
What core steps seem to consistently lead to better results for you, no matter the specifics?
Thinking about that, how over what mentality, it could genuinely unlock new efficiencies, maybe some unexpected adaptability, wherever you apply it.